Yes. So we're talking about indifference curves, all right? This is an indifference curve. This is how it looks. Okay, looks like that. Okay, you have code y on the y-axis, you have code x on the x-axis. This indifference curve is just showing the combinations of good y and good x whilst you're maintaining the same utility, the same satisfaction. Okay. So if you have, let's say good y is sausages and good x is rice. Let's say here at point A, you have 10 sausages and you have one bag of rice. All right. Then let's say here point B, point B here you have 8 sausages and 2 bags of rice. All right. Then let's say you have point C here, 5 sausages and 3 bags of rice. Okay. So if you have 10 sausages, 1 bag of rice, or 5 sausages and 3 bags of rice, your satisfaction is going to be the same because they're on the same utility curve here. Okay. Any point A, B, C, any point on this curve, your satisfaction, your utility will be the same. That's why we're saying indifference curve. Indifference means it doesn't matter if you have 10 sausages and 1 bag of rice, or 8 sausages and 2 bags of rice, or 5 sausages and 3 bags of rice. No matter those, whatever combination it is, your satisfaction is going to be the same. Okay. So marginal rate of substitution, which I said is the trade-off rate. How much of good y you need to give up to get one more unit of good x. Okay. So if we move from point A to B, okay, you've given up 2 sausages here. Okay, from because you had 10 sausages, now you have 2 sausages, so that you get one more bag of rice. Okay, so your marginal rate of substitution, MRS, is 2. Okay, given up 2 sausages to get 1 unit of rice, 1 bag of rice. If we move from point B to point C, all right, from 8 sausages, you have now gone to 5 sausages. Your marginal rate of substitution is now 3 because you have given up 3 sausages. Oh, actually, it has to be diminishing. I made a mistake. This has to be diminishing. Let me put it like this. So we'll start 10 to 5, then 5 to 3 here. Okay. Uh-huh. From A to B, you've given up 5 sausages. Okay, so your marginal rate of substitution is 5. Okay. Then from B to C, you have now given up 2 sausages. Okay, your marginal rate of substitution is now 2. Okay. We can even add a point D here. Point D here. Let's say here this is 2 and here 4. Uh-huh. So moving from point C to point D, you have given up one sausage. Imaginary rate of substitution is 1. Given up one sausage in order to get one more bag of rice. So this is what we mean diminishing marginal rate of substitution, okay? You're giving up less of good Y in order to get one more of good X. This is what we're meaning the diminishing marginal rate of substitution, where your trade-off rate is dropping. You're giving up less of good Y, giving up less sausages in order to get one more unit of rice. Okay. So mathematically, this marginal rate of substitution, MRS, equals the marginal utility of good X over the marginal utility of good Y. When we say marginal utility, it just means the additional satisfaction. So marginal utility of good X is the additional satisfaction you're getting from consuming one more unit of good X. When we say marginal utility of good Y, this is the additional satisfaction you get when you consume one more unit of good Y. Okay, so let's now apply the mathematics. Okay, let's say you've been given a utility function like this: U equals X to the power 0.5, Y to the power 0.5. Okay, so these exponents, they just tell you which good you prefer more. So if you see 0.5, 0.5 here, it says you treasure good X and good Y the same way. Okay, you don't prefer one over the other, you prefer them in the same way. And then they ask you find the marginal rate of substitution, MRS. So it means you have to use differentiation. This is where calculus is now coming in. Okay, so remember marginal rate of substitution, marginal utility of good X over marginal utility of good Y. So first, let's find the marginal utility of good X, okay, which equals, we're going to partially derive the utility function with respect to good X. Okay, meaning when we derive, we're focusing only on good X. So deriving, remember, multiply the exponent with the number in front. Here there's an invincible 1. So 0.5 times 1, that is 0.5. So we're going to have 0.5 x. Then remember, when we derive, colleagues, we subtract a 1 from the exponent. 0.5 minus 1, that is negative 0.5. Okay. Y to the power 0.5. Okay, that is the marginal utility of good X. All right. Then for good Y, marginal utility of good Y is the partial derivative of the utility function with respect to Y. Okay, so it means we're deriving this utility function with respect to Y. So how we're going to do that? You come to the y power here. You're going to say 0.5 times 1. You get 0.5. 0.5 x to the power 0.5. Okay, then you have y here. So remember, you always subtract a 1 from the exponent. 0.5 minus 1, that is negative 0.5. Okay, this is the marginal utility of good y. So when we say the marginal rate of substitution, so you say MRS equals M MX over MUY. So that would be 0.5 x to the power negative 0.5 okay, y to the power 0.5 over 0.5 x to the power 0.5 okay, y to the power negative 0.5. So we need to simplify this expression, colleagues, all right? We need to simplify this expression. The 0.5s cancel each other out. Then remember, for mathematical analysis, indices, when you're dividing same bases, you subtract the exponents. Okay, so for x, you're going to subtract. For x, we're going to say we are subtracting this negative 0.5 minus this 0.5. Okay, so for x, you say x to the power negative 0.5 minus 0.5. Then for y, you are going to do the same thing. Okay, you're also going to subtract the exponents. You're going to say 0.5 minus negative 0.5. 0.5 minus negative 0.5. Okay. So negative 0.5 minus 0.5, that's negative 1. So you have x to the power negative 1. Then 0.5 minus negative 0.5, these two negatives make positive. So 0.5 plus 0.5, that is 1. So you have x to the power negative 1, y to the power 1. So remember, with negative exponents, you bring them at the denominator. Okay, so your marginal rate of substitution is y over x. Okay, yes. Any questions? So when we combine these two things, the indifference curve and the budget constraint line. This is where we get our optimal condition. Okay. Now, this is our budget constraint line, and this is the indifference curve. So where they touch, okay, where these two touch, this is the combination of good X and good Y that will give you the most satisfaction. Okay, colleagues, this is this point here where the indifference curve and the budget constraint line touch. This gives you the combination of good Y and good X to give you the most satisfaction. Okay, so if maybe let's say 3 units of good Y, 2 units of good X. So as a consumer, if you get 3 units of good Y and 3 units of good X, it means that is the combination that will give you the most satisfaction. Okay, so this can be represented mathematically like this. Marginal rate of substitution equals the price of good X over the price of good Y. And if you remember, the marginal rate of substitution is MUX over MUY equals PX over PY. Okay. So this is the condition for maximum utility, maximum satisfaction. So in a question where they ask, what is the combination that will give the most satisfaction? You need to equate these two equations. So this is one formula you need to remember. Okay, it's just that time is up. But when we meet next time, we're going to see how we can calculate this optimal bundle. Okay, when you hear optimal bundle, it just means the combination of good X and good Y that will give you the most satisfaction. Yes, optimal bundle.